Hello to everyone. I am Roberto Verdecchia of the Vrije University of Amsterdam. In this presentation, I'm going to provide a brief overview of my doctoral dissertation titled Architectural Technical Debt Identification and Management. Just to provide a brief overview of what architectural technical debt is, we consider it as a set of architectural design and implementation choices, such as choices regarding the structure of a software system, the technology used, the languages the system is implemented in, and so on and so forth. And these choices are made early for expediency, but are preventing further development today. To put it in simpler words, it's the stuff that it's very hard to change now while hurting us a lot. The goal of the thesis was to answer the question, what strategies can be used to identify and manage architectural technical debt? And to kickstart the project, we inspected the literature, and specifically, we conducted a systematic literature review based on 47 primary studies to analyze the abstraction levels of the identification approaches, the analysis types, the resolutions, and so on and so forth. And through this study, we identified different research gaps, which we tried to fill in by presenting the ATDx. And what ATDx is an architectural technical debt index. It's the first index based on inter-project comparison and uses artificial intelligence to calculate the severity of architectural debt issues based on the comparison of the debt present in different projects. We evaluated the approach based on the analysis of 237 projects. And then we surveyed the developers of the projects to get their feedback on it, which was vastly positive. The tool is now available on GitHub as an open source project. At the same time, we also asked ourselves, are we missing anything regarding architectural technical debt? And to answer this question, we conducted a grounded theory, which then we validated via focus groups. And in this theory, we identified 9 core categories, such as the causes of architectural debt, the consequences, and so on and so forth. And then we further characterized these categories with 63 concepts. And then we also studied the relation between these concepts and categories, building a comprehensive theory. We also noticed during our research that there were no studies which tackled architectural debt in Android systems. And since there were no studies, we kickstarted this exciting project by making a deep dive into the maintainability issues of Android. In order to do so, we conducted a static analysis of 1.4 thousand applications to gain insight on the maintainability issue types which are present in Android applications, such as code duplication, the evolutionary trends of maintainability issues, and the development activities which are more likely to cause maintainability issues. Based on these findings, we're able to tackle architectural debt in Android. And we did this by designing the first approach, which is able to identify architectural technical debt hotspots in Android. And this approach is based on guideline instruction, reverse engineering, and then compliance checking with respect to a reference architecture and the reverse engineered architecture. At the same time, we also conducted a mixed method empirical studies to gain insights on the architectural practices in Android, and at the same time to present 42 guidelines to architect Android apps and keep the architectural technical debt low. This concludes my short summary of my doctoral dissertation. I'd like to thank you all for your attention and take care.